One day, you wake up to the news that we've picked up an alien signal. No uncertainty or ambiguity. It's an alien TV channel, and within a few days, we've picked up other stations and decoded them. You can watch them live, but a few weeks later, they all just stop. Nobody knows why, and soon thereafter, we realize we've just been introduced to the biggest murder mystery in history. Our topic today is extinct alien civilizations. Something we see a lot in science fiction and often contemplate when discussing the Fermi Paradox. The apparent contradiction between the vast size and age of the universe and the seeming absence of any intelligent life in it. One of the most common suggested explanations for that paradox is that intelligent life is prone to killing itself off. In one of the oldest episodes on this channel, Apocalypse How, we explored that possibility and found many apparent weaknesses in the argument. Those weaknesses, though, were not in the notion that many civilizations might kill themselves off, but rather that it could be the case for such a large percentage of civilizations as to answer the paradox. We saw that many of those catastrophes were much less likely to kill intelligent life off than folks often assume, but a few of them did leave the door open to a total extinction event. Again, it wasn't the idea that such things rarely, if ever, happened, but rather that they couldn't be a strong solution to the Fermi Paradox unless they were getting virtually every civilization. In the Fermi Paradox, we often have what we call filters, factors or steps in the process of becoming a civilization that can lower the odds. We went through 50 of them in the Fermi Paradox Compendium episode, and we listed ourselves as having already gotten through the first 48 out of 50. In that episode, I defined the remaining two as 1. Not falling victim to self-annihilation, blowing up your planet, basically. 2. Having both the ability and desire to colonize other solar systems. Almost every proposed solution to the Fermi Paradox includes all these filters, but often with one or more considered stronger or weaker. For instance, even folks who think the galaxy is full of thousands of spacefaring civilizations tend to assume not every planet spawns life that evolves to intelligence. Alternatively, even folks like myself, who tend to be very optimistic about those last two filters, not blowing ourselves up and colonizing the galaxy, believe there's a chance we might do the former or not do the latter. We do not know the odds of a single one of those filters, or if there may be others. In the compendium, I arbitrarily said each was 50-50 to highlight how such odds could compound to make spacefaring civilizations very rare, even though no single step was improbable. If each step was 50-50, coin flip odds to become a spacefaring civilization would require flipping a coin and coming up heads 50 times in a row. The odds of that are 1 in 250, or about 1 in a quadrillion, which is a few thousand galaxies worth of stars, and makes even civilizations like our own at step 48 out of 50 so uncommon you'd find about 1 for every 1,000 galaxies. Those numbers were selected arbitrarily for an easy example of compounding improbabilities. Kick those odds down to just 1 in 3 per filter, and the final odds drop to about 1 in a trillion, more stars than in the observable universe. Bump them up to 2 and 3, and the total odds jump to just 1 in a billion, which would imply a few hundred civilizations in our galaxy alone. We have no idea what the probability of a single one of those steps is, not to even that wide range of accuracy, 50-50, 1 in 3, or 2 in 3. Just that amount of variation radically shifts the environment. Whatever those odds are, they won't be the same for each filter. Some might be 50-50, others might be paper-thin barriers that 90% of the time get passed through. Some might be the reverse, far less likely than even 1% to be passed through. We tend to call these kinds great filters, ones that just by themselves drop the odds of spacefaring civilizations down multiple orders of magnitude. This series is not about the Fermi Paradox, though. That has a series all of its own that you can watch, and we will be revisiting it again soon. But it's this kind of thinking we have to keep in mind when giving the topic serious thought, rather than just going with the classic space opera notion that there are civilizations all over the place, typically with one within 100 light years of us, and maybe 10,000 years older than us at most. When you start contemplating the numbers on things like that, it breaks down. Let me demonstrate. Let's imagine that case for the moment. that in a bubble of space about 100 light-years in radius, we could expect a technological civilization to arise every 10,000 years. There are a few thousand stars within such a bubble, and odds are most have planets. A pretty good portion of them probably have rocky planets close enough to their sun for water to be possible. We'll say 1,000 to keep it even. If we are assuming a new civilization popped up in that bubble every 10,000 years, we would expect each of those planets to have spawned a civilization every 10 million years. The universe is over 1,000 times that old, and while we can hardly say for sure, we have no particular reason to think life couldn't have existed long before it formed on Earth, nor evolved to complexity faster than it did here. But it's entirely possible. Most extinction events don't totally sterilize a planet. In fact, all the known means that we could realistically employ wouldn't have very good odds of killing most people, let alone all of them. And getting every single organism would take some doing. Some life would probably survive to repopulate things and let it evolve again, and probably with a large head start. We are the first technological species on Earth, but that's something we could only have said with much certainty in recent times. You could easily have a place where every few million years, civilization evolves again, then wipes itself out, layering up civilizations like a lot of ancient cities. We discussed the problems with that sort of cyclical extinction scenario in the episode, Apocalypse How. But this is also a common theme in science fiction. And that's the only way you could get civilizations popping up that close to each other in time and space. Nearly every system spawning civilizations and over again to boot. Let's slim down the odds a bit and discuss a scenario where maybe just 1 in 10 stars has given rise to a civilization, and just one time, and just in the last billion years. And we'll say there was a 10,000-year window when we might notice them by radio transmissions or other indicators. In such a scenario, only 1 in a million stars would host such a civilization at any given time. Such being the case, if we set a bubble on Earth 1,000 light-years in radius, odds are we would have at least one active civilization besides ourselves inside it, possibly a few. Those would be close enough for us to hear with modern equipment if we were looking at the star at the time, if they transmitted like we do now. Past this scale, the galaxy gets a bit more two-dimensional, turning into a disk, so if you doubled your bubble size, you'd only quadruple the number of civilizations in it. However, we would again be assuming 1 in 10 had hosted an emerging civilization at some point in the last billion years, and that there were a few hundred within 100 light-years of us. Let us assume that this is the state of play in a couple of centuries when we have our first manned interstellar ships go lumbering out into the stars. Now, if you want to look at what those ships might be like and the problems traveling through space, you can watch the Life in a Space Colony series and the Interstellar Travel Challenges episode. Those of you who have already seen those will remember our example ship, Unity, that we last visited when it was leaving the Tau Ceti system and heading for 82G Eridani at 20% the speed of light. As I mentioned at the time, 82G Eridani is a G8 yellow sun, 20 light-years from here. It is about 74% as bright as our own sun and is thought to be at least 6 billion years old. It has been considered a strong candidate for habitable planets for a long time now, and has shown up in a lot of science fiction, and we've also found a few planets around it. Those are bigger than Earth and too close to the sun for life, but that strongly indicates there are more planets, as we discussed before. Most methods for finding planets can most easily find large ones, or ones near their sun, so if you have a few large ones that are also near their sun, they are much easier to see, and probably indicative of other planets we can't see yet. So 82G, Eridani is an old star, more than 1 billion years older than our own, and will live long too since it's less massive. If I had to pick a place near us most likely to be home to an extinct civilization, it would either be 82G Eridani or Delta Pavonis, which is also a G8 yellow star, 20 light-years from us, and billions of years older than us. Since we already have a ship headed to the former, we will make G Eridani our example for today. Here's the first big thing about extinct alien civilizations on their dead planets. Most of the time, you won't even know you're walking around a graveyard. That extinct civilization is much more likely to be hundreds of millions of years dead than hundreds. You won't likely see ruined skyscrapers like we often picture with extinct technological civilizations, or even stone structures like we see with our own ancient civilizations dead and gone a few thousand years. If you are visiting a solar system 1 billion years older than your own, it is much more likely they were dust and ashes before dinosaurs roamed the Earth than kicking around while we were learning to bang rocks together to make tools and fire. Very few things will last even 1 million years. The pyramids might, but they would likely be buried and look like hills after that much time. A collapsed skyscraper probably would too. This does not mean you wouldn't be able to find stuff clearly showing technology once existed, but it won't likely be obvious from orbit. Now that said, a lot depends on how the planet died. If you blow your atmosphere off in some fiery atomic holocaust, things probably won't corrode and decay nearly as fast. For instance, but more importantly on that theme, the kind of technologies you need in order to kill off your population for keeps are generally the same that let you get stuff off a planet. Maybe not manned bases and colonies, but at the very least probes. Many planets have moons. Not necessarily big ones like ours, but even modestly sized moons are likely to have been visited, and possibly more likely since, for example, Mars's 2 moons are both way closer to their planet than ours is. Before we jump for joy at the notion that we are likely to be able to see remnants of their civilizations on their moons in eternity later, let me dampen that a bit. The moon is literally covered in craters, and craters on top of craters, and they didn't just all show up one night, then stop. The frequency of impacts is going to vary from system to system, but should follow the normal inverse relationship of size to frequency. Smaller stuff hits more often. Our nice lunar landers we left behind on the moon would still be there and intact for a long, long time if we cease to exist tomorrow, but time will still take its toll. Small meteors will hit. There's no atmosphere to burn them up, and they'll scratch or punch holes in the object. On top of that, every strike nearby will kick up a little bit of dust that settles back down, and over a long enough time, it will bury that lander. Heck, over a long enough time, a bigger meteor might thud down right on top of it. Not all moons are particularly stable. Sometimes they get ejected from their host planet or decay and fall on them. But they will last a long time, and we will assume that's what we first notice when our colony ship Unity arrives in the system. They find a nice Earth-sized planet in the habitable zone and want to check it out. They probably knew it existed before they ever left Tau Ceti, and maybe had probes arriving ahead of them taking photos. Now, a common dilemma in science fiction is what to do if you find a planet with life already on it or ruins of a civilization. But that's not too much of a dilemma for colonists. As we discussed in the Life in a Space Colony series, while planets are probably always going to be viewed as prime real estate, they are not the first thing you colonize when you get into a new solar system, nor do you really need them. So we will say they knew about the planet and had probes arriving taking closer looks at it that got there a few years earlier. I will go ahead and name this planet Amber. Since Eridani was a mythical river rich in amber, and since amber is fossilized tree resin, and we often find ancient tiny critters like mosquitoes encased in it, so it seems an appropriate name for the home of a fossilized civilization. We will also say it has a moon, a bit smaller and closer to amber than ours is to Earth. We will call the moon Shiva, since that deity is associated with what the Eridanus constellation is called in Indian astronomy. Shiva, of course, also being a rather appropriate deity when discussing extinct civilizations. So the moon Shiva around the planet Amber in the 82G Eridani system, 20 light-years from Earth. Our colonial arc is in the middle of its long deceleration when they get photos back from some probes that did a flyby of Amber and Shiva, and they see some nice shiny patches. Now, this is a colony ship. They are not on a 5-year mission to explore strange new worlds and seek out new life. They are on a millennia-long mission to establish colony after colony. Yet they've contemplated the possibility of encountering alien life, and we'll go ahead and say that this isn't the first time. We'll say that their sister ship, the Nostalgia for Infinity, found the remnants of an extinct species on a planet in the Delta Pavonis system, bird-like people 1 million years dead. They got word of it a few years back, so they've been discussing the possibility since they figure they will eventually encounter such a planet. They've already come to grips with definitive proof civilizations are decently common, so when they see a few small bright patches on the moon Shiva, they send some slower probes ahead for another more detailed flyby and get reports back just as they are entering the outer solar system. So the captain calls a meeting, and the first thing she asks is if this is aliens. The science officer says, "Oh yeah, they have spotted an antenna mast on a crater rim near the North Pole of Shiva. It looks like they erected a mast with some solar panels on it, and the height and angles would have better protection against meteors, though they would have put it there to take advantage of the near-perpetual sunlight." She asks what else they have detected. Anything big enough to be a base or a colony. The science officer says no, but that absence doesn't mean anything. They probably would have built any large structures underground to add protection from meteors and radiation, or at least have used local regolith to help construct the buildings, and they can't see that well yet. Those probes were flicking by at modestly relativistic speeds after all. They didn't get a good look. She asks about the planet, but the science officer just shakes his head. Amber is one large snowball. Assuming the original inhabitants weren't Yetis or Vandals, whatever killed them dropped the planet's temperature enough to ice it over. And while the atmosphere is not too thick, indeed a lot thinner than on Earth, it's still interfering with their pictures. So what do they do next? Of course, they plan to investigate, but they decide to get the usual colony infrastructure going first on the moon of a local gas giant. They will comb over those moons too, looking for a possible probable base. But they decide to begin the investigation by going to Shiva. The captain dispatches a shuttle there with personnel and equipment. They decide to land the shuttle near the crater where they spotted the antenna mast. The reason being that you wouldn't build something like that during a quick manned mission like the Apollo landings, let alone for an unmanned lunar rover. So if there was a base, this should be the spot. They start by looking at the mast, and it's in bad condition. The solar panels have vanished, or are heavily pitted with meteor damage and scratched up, and it looks like a meteor came by and severed the top of the mast too. After some poking around, they find a couple meters of antenna buried under the dust nearby. The astronomy and geology experts put their heads together and give a rough age of 2 to 4 million years to the antenna. They base this on the amount and size of the pitting in the panels and the depth of the dust. This is good and bad. Obviously, the younger it was, the more likely it was to yield information. But it's actually a stroke of luck to have found something only a few million years old, not a few 100 million, or even a few billion. Our science officer doesn't think so, though. He notes that this site and the million-year-old one at Delta Pavonis stretch credulity. Using the Maabo mediocrity principle, which tells us to assume random samples should be assumed to be pretty ordinary, he now has 2 civilizations inside a 20 light-year radius of Earth that are less than 4 million years dead. By that reckoning, it stands to reason life is so insanely common, we'd expect 3% of stars to have hosted civilizations in the last 4 million years, which would imply that galaxy-wide about 12 billion civilizations have existed during that time. 3 billion in the last million years, and 3 million in the last 1,000 years. The only silver lining is that the 2 they discovered so far don't show signs of interstellar flight yet, so there's a decent chance that discovery is still quite real. And that, as high as the probability now seems that species tend to wipe themselves out, humanity might have already passed that point safely, that we won the Maat doomsday lottery. With that cheerful thought in mind, he goes ahead and installs a doomsday lottery with the rest of the Scratch archaeological team on Shiva. And I say Scratch archaeological team because you wouldn't really expect your average colony ship to have a lot of archaeologists on it. So they get a betting pool going on what the cause of the death of the Amberites was, while they hunt for the hoped-for moon base. Atom bombs, a plague, chemical biological warfare, and so on. The ship's computer tosses in a bet on rogue AI rebellion killing off the meatbags that enslaved it, and everyone chuckles nervously and awkwardly. Fortunately, the tension is broken when one of them spots what looks to be a collapsed cave in the crater wall. They shine some lights in there and see a metal door with some weird symbols on it, recessed a few meters back, but with a bunch of boulders blocking the path. Someone suggests they go get some heavy lift equipment or explosives to move the boulders, but one of them snorts and starts chucking the 1-ton boulders off the side, like they are made of papier-mâché, and reminds everyone that the gravity here is around 10% of normal. Excavation is very easy in low gravity. Now, it is a bit of a truism that the more advanced technology is, the quicker it decays. Stone Age technology and structures tend to be fairly enduring since it's just rock, whereas paper tends to fall apart a lot faster, and circuits and microchips, while they might be durable, part of the reason for that is that we don't bother making something like a circuit or microchip long-lasting when we expect it to be an antiquated hunk of junk in a couple of decades anyway. We can build things to last a lot longer, but this would often come with it being more expensive and less efficient. Of course, that situation has changed a lot when you suck all the air out of an environment, and where there is no erosion or meteor strikes to worry about. It is possible that the door we are now looking at might still function. It does not matter, though, because we are not going to try to open it. They are very used to dealing with airlocks and have tools for working on them, which would include a drill they can use that will maintain a pressure seal. They are going to drill a hole in the door and insert a camera, of course. In the meantime, while someone is fetching that drill, they are photographing this door and cave entryway with every camera they've got and every frequency of light they can, especially the strange symbols. Odds are those symbols are what you expect to find on a door. Possibly the word for hello or the name of the base, but most likely stuff like stand clear of the airlock when opening, or check suit pressure seals and stuff like that. Possibly manufacturer names and serial numbers. As we saw in the episode Cryptic Aliens, even stuff like that can be quite handy for deciphering a language. If you've got a bunch of serial numbers, there's a good chance you will be able to find out at least what base they did their math in and what symbols are their numbers. Of course, when we get through that door, we will find an empty room with another door on it, because that's just how you build an airlock. The important thing is we find out the room is not pressurized, so we can go ahead and open the door, which we do by removing the entire thing, since we want to disassemble it, and look for every symbol we can that might be stamped on the parts, and see what we can learn about their mechanisms. Odds are the door represented the height of their technology in some respect. That seems a bizarre statement, considering our own doors are a lot like the ones our ancestors made and usually aren't very high-tech. But this is an airlock on a moon, not the door to your closet. What's more, something like the ball bearings, or how the metal was made or cut, could tell us a lot. We will probably replace the door, but we have no intention of pressurizing the space so that we can walk around it without suits on. Odds are good there was no air left in there. Some tiny crack or leak would probably have vented it. Repressurizing it will expose stuff to oxygen, which is quite corrosive, maybe blow stuff around in the process, and quite a few other things which might screw with our sight. We will drill the next door too, and every time we encounter a closed one inside, since there's always a chance one might have some residual gases inside, we could sample. One thing we notice as we go through is that the whole place is a vacuum. Not too surprising. But our guys know space life support systems quite well, and it looks like someone actually opened the place up to drain the air. Not fast. The airlock doors were not open, but like they wanted the complex to empty of air in an hour or so. Not fast enough to blow stuff around. Now we could do whole episodes on exploring a place like this, on what we can determine from this or that artifact and mummified body we find. Archaeology is a fascinating field of study, even without the kind of excitement folks like Indiana Jones or Lara Croft experience. Every mundane object we find inside has the potential to tell us whole volumes about the species that made it. However, we are going to skip to the conclusion. This was a moon base, staffed by a small crew of 20 or so. When the end of the world came down on Amber, they decided they could not go on, and we find civilizations in a situation like that. If you know you can't survive or choose not to try, if you think there's not much chance, what would you do? It's good to have a purpose when you're living on an hourglass that's rapidly emptying out of sand. After I had ascertained that survival wasn't a realistic option, I'd try to archive my civilization so someone else could learn of it later. Maybe visiting aliens like our guys, maybe survivors on their own world that piece civilization back together 1,000 years later, maybe a second evolution of intelligent life from whatever organism survived. Here's the picture of what happened to those aliens then, when their homeworld died, and one of the reasons why we decided to go to this moon base first, rather than going down to visit Snowball Amber. They knew the jig was up, and they'd run out of supplies. They were a lot like us in many ways. Had 2 eyes, ears, 2 arms, 2 stomachs, 6 legs, etc. Practically a clone of us, at least in every way that mattered. They decided they wanted to leave what they could behind. So after a lot of prep work, when their supplies were almost gone, The last two of them sat down together for a last good meal after weeks of tight rations, took some sleeping pills, arranged their bodies to be easily found, and opened the vent to drain the air out, slow enough not to disturb things, but fast enough to keep them from rotting. Then they fell asleep and didn't wake up. Inside this place, they tried to store things to last and made copy after copy of historical records on every memory device they had. They also carved history and information into every metal surface they could find or manufacture. Not every bit of metal, though. Some they polished up and took outside and stuck up as signs pointing to the base. Just shiny metal sheets, elevated a bit off the ground and angled so the dust wouldn't build up too much. Those are some of the things we saw when our probes did a flyby. On those walls and metal sheets, we find most prominently something to serve as a Rosetta Stone, and the events that killed them and their world. It doesn't matter what. Something that killed mostly everyone, and afterwards changed the composition of the atmosphere to make things colder so the planet iced over. But we find something else too. The shiny arrows mostly point to the base, but near them, some point down at the bottom of the crater, and our science team suddenly knows that these guys probably did not just give up and die after all. Back here in our solar system, the coldest place we've ever measured, colder even than Pluto, is the bottom of some of the craters on the poles of the moon. It can get down to just 26 Kelvin. We find most of the base personnel buried down there with some possessions, even food, like the ancient Egyptians used to do. We figure maybe they sacrificed some of their last precious food to give their dead something to make their journey into the afterlife with. But then we think maybe that's not what they did. Or rather, in a way, that is exactly what they did. Pack food to journey with them to the next life. Even the vacuum and temperature so cold it will turn oxygen into a solid ice is no guarantee of perpetual preservation. But they took a gamble that it might make the bodies last long enough that someone might be able to find them. They buried their colleagues down at the bottom of that crater, with biological samples and more copies of data, including genetic data. They gambled that someday someone might be able to find them and bring them back. Not just learn of their civilization, not just maybe use digital records of genetic information hot-coded onto sheets of metal, but maybe even they themselves. It was slim odds all around, especially on that last option, but they had nothing to lose. That food isn't for eating. It contains genetic samples of what they did eat. They may have etched copies of their DNA into metal and burned it onto memory crystals or whatever, but they tried to leave the real deal around too. Now, whether or not DNA would survive a few million years even at those temperatures is hard to say, particularly since we don't know that it would be DNA. There's no guarantee they use anything like the same biochemistry we do. On this channel, I tend to use DNA as a bit of a blanket term for organism blueprint, just a shorthand. Not only might they not use DNA, but there's a lot more entailed in creating an Earth organism than just its DNA. And that is likely to be pretty different for them too. We can't just take samples they gave us, especially the digital ones, and cook up some amberites. But the crew is quite experienced in restoring frozen bodies. They do it fairly regularly. We discussed that when we first introduced them back in Life on a Colony ship. They can freeze and restore people, and they have the nanotechnology to repair cellular damage. That's why in that series of episodes, the captain was a few centuries old herself, and our crew contains a lot of cyborgs. A topic we discussed before, and will discuss more soon. But these folks have gotten quite skilled at repairing, cloning, or mechanically replacing damaged tissues. And so she asks them the question, can you bring these aliens back? The science officer says the answer to that is yes and no. That they might not be a perfect copy, but that we first need to decide if we should do it. It's not easy. They can't just take the bodies to sickbay and raise them sometime tomorrow. To do this, they are going to need to spend years learning their biology and their civilization too. What's more, if they can bring them back, this is their moon, their planet, their solar system, and we are working to colonize it for ourselves. This represents a bit of a tricky issue, especially since this won't be a unique case. Two civilizations found this recently in time, and this close to Earth guarantees they will be finding civilization after civilization out there. If they do revive these guys, it establishes a precedent. They could end up sharing the galaxy with a lot of ancient civilizations, some of which might not be too friendly. He also says that even if they can clone up new Amberites, they won't have the memories of their culture, and while they have a lot of genetic info, much of it is damaged and it's anything but comprehensive. They might have a few hundred intact or mostly intact samples of DNA from amber, not a whole ecosystem with millions of species. The science officer speculates that they might be able to restore the dead bodies they found, take high-resolution scans of everything, and pump in enough computing power to guess the layout of whatever passed for an amberite brain and maybe restore them with nanomachines, with most of their memories intact. They can probably have extrapolated their language and culture enough by then to be able to talk to these guys. Or rather, for the colonists they'll be leaving behind to do so. They have their own mission and will continue it to the next solar system. The actual colonists can communicate back to Tau Ceti and Earth for advice if they choose, or make that decision on their own. So this raises a lot of questions. Even assuming they can restore these organisms, or at least guess their way to a close enough approximation from the available data, damaged in some cases, it isn't a guarantee they can restore those specific dead amberites with their memories intact in whole or part. If they can't, they're going to have to raise the new amberites they grow in a tank entirely on their own. Ditto every single organism, and the more complex ones might be kind of tricky. A kitten or a puppy has more than just biological needs from their parent, after all. Their parent teaches them to hunt, to hide, that sort of thing. Restoring that civilization is going to be a long-term task, probably one where the first few generations of them aren't very like the originals in behavior at all, and you might be working with them to try to restore their civilization as best you can guess it. They'd essentially be half-human hybrids, even if their genetics was all correct, just from having been raised by humans. It is also possible that buried under that ice down on planet Amber are some living organisms. We've got life way down in the bottom of ocean trenches that would probably survive even a local supernova that sterilized the surface of the planet. You might also later on encounter a scenario in another system where some decently complex organisms had survived and had a good head start getting to intelligence. The equivalent of raccoons survived and are now a thriving Bronze Age civilization. When you find genetic data on their moon too and are faced with a conundrum, do you bring back the old civilization that went extinct and got replaced? Is it even ethical to consult the new species about doing that? Should they have a say? What about the species you did bring back? If you help them restore their planet to the way it was, while colonizing various asteroids and moons for yourself, and for the infrastructure and resources to help restore their planet too, do they have the right to kick you out of their solar system? What about nearby colonies and other systems? Should they have a claim on those on the grounds that everybody deserves some other places to colonize, and the ones closer to home are the most logical? What do you do if Earth calls back and says, don't do it? What crime, if any, would you charge the captain with if she said the risk was too great and ordered an orbital strike on the moon base and its tombs of people and knowledge? What if she packed up only the folks who agreed with that decision to go to the next colony and stated her intent to repeat that destruction every time they encounter such a tomb again? What if back on Earth you decided that was a monstrous crime? Would you build a fleet to go chase after the ship that's got a 20-light-year head start and probably centuries of comm lag and travel time to buffer that lead further? And we still have the mystery of what actually killed the civilization. We talked about some of the options for ending civilizations way back in the Apocalypse How episode of the Fermi Paradox series, which we will be revisiting again soon. Also, unlike some of the episodes in the series, we didn't reference a lot of fictional works, but there are many. In fact, we actually did reference one. One of my favorite science fiction novels, and by my favorite author still alive and writing, Alastair Reynolds, begins with an archaeological dig in the Delta Pavonis system. That novel, Revelation Space, is definitely worth reading, as is a short story set in that universe titled Glacial, that talks about bringing a frozen survivor of a colony back from the dead. There are, of course, tons of examples of extinct aliens in fiction, even going back to H.P. Lovecraft's At the Mountains of Madness. It's always an intriguing topic to cover because it lets you discuss archaeology, astronomy, aliens, and forensics all in one go. One part alien civilization, one part murder mystery. For my part, though, I think it will be confined to just fiction. I rather doubt our galaxy has ever hosted another technological civilization besides ourselves, and you can watch the Fermi Paradox series to get the reasoning behind that conclusion. And again, we'll be revisiting that series in the next month or so. Next week, however, we will be heading back to modern Earth and the Upward Bound series for a look at reusable rockets, a promising technology that is making space travel a lot cheaper in the here and now. The week after that, we will be jumping a bit ahead in time to visit transhumanism concepts in an episode on Ichabodi cyborgs. Until next time, thanks for watching and have a great week.